Alright, so what should we do with this save changes method? Well, one of the mistakes that I have seen a lot of developers make is that they add this method to their repository, repository.savechanges or save changes async. Why is this bad? Because repository is a collection of objects in memory. Think of any collection classes in .NET, like list of integer. Here we can add an object to this list, we can remove an object, we can find an object, but we don't have a save method. It doesn't make sense. We don't have an update method here. It doesn't make sense. So by definition, your repository should not have a save method because you should treat it like a collection of objects in memory. The second reason this approach is bad is because in a more complex application, as part of a transaction, you may want to work with multiple repositories. So let's say we have order repository and also shipping repository. Now, as part of this transaction, I'm going to add an order here, and at the same time, I'm going to add a shipping object here. Now, when this transaction completes, I want both these new objects to be persisted in the database. So if I add a save method to my repository, order repository.save, then this is going to persist only the new order, not the shipping object. So then I have to come back here and call shipping repository.save. But what if one of these calls to the save method fails? Then we'll end up with a bad state in our database. Of course, we can wrap this in a transaction, but this is just pure ugly. Your repositories should not have a save method. This line delete, this line delete. Now what we want is a unit of work. Unit of work is a pattern that goes hand in hand with the repository pattern. So here we're going to have another object, unit of work.complete. So I add an order to order repository, a shipping to shipping repository, and then tell my unit of work to complete. And with this, both these new objects will be saved in the database together. So let's go ahead and implement a unit of work. So back in the persistence folder, first I'm going to add a new interface, iUnit of work. Here we need only one method, task complete. Just that. Now here I'm going to immediately implement this interface. So public class unit of work implement iUnit of work. Command and period. Now I'm going to add a constructor, unit of work. Here we get a DB context, so a vga DB context. Initialize field from parameter. Good. And finally, in the complete method, we simply delegate to this context. So context.save changes async. Of course, we need to await this and mark this method as async. So once again, we are separating what changes from what doesn't. We're encapsulating this DB context inside this unit of work. So in a larger application, we'll use DB context in our unit of work and the repository classes. That's it. Nowhere else. These repositories may be reused in 10 or 100 other places. And if you want to replace DB context with something else, we don't have to go and modify all these million places. We only modify it in our repositories and the unit of work. Now I'm going to move this unit of work class to a separate file. Okay, that's cleaner. Next, we need to register this iUnit of work and its implementation as a service for dependency injection. So we go to the startup class. In configure services method, services.add scoped iUnit of work and unit of work. Now we go to our controller. And here in the constructor, we add a new parameter, iUnit of work. Unit of work. Let's initialize field from parameter. Beautiful. Now finally, anywhere we have db context.save changes, I'm going to replace with unit of work.complete. So first here in create vehicle action, unit of work.complete. And in fact, it's better to change the name of this method to complete async, just to follow the convention in .NET. Next is the update vehicle action. So here, unit of work.complete async. And finally, in delete vehicle action. So one more time, unit of work.complete async. Now, one last thing. Let's see if we have any references to this DB context in our controller. So Shift and F12. There is only one reference, which is in the constructor. So if I remove this line here, then I can safely remove this parameter from this constructor and also delete this field here. Now look at the end result. Nowhere in this class we're referencing Entity Framework. Nowhere we're using DB context. Nowhere we're using DB set. We are programming against interfaces. So we have three dependencies: IMapper, iVehicle repository, and iUnit of work. And with this, our controller is completely decoupled from Entity Framework. And this means if in the future I want to replace Entity Framework with something else, it's going to be a lot easier. And also during unit testing, I can supply fake implementation of these interfaces, like a fake repository or a fake unit of work that does not talk to a database. So once again, we have separated what changes from what doesn't. We have moved this DB context inside our repository. We have encapsulated it inside this repository. Nowhere in our application, nowhere in our controllers, nowhere in our domain classes, we have a reference to DB context or DB set. So this is the benefit of decoupling your application from Entity Framework. Next, I'm going to talk about some common false arguments about the repository and unit of work patterns.